Hey everyone, this is Andrew Zidell, your friendly neighborhood physicist. Today we're going to talk about space pinball, or what killed the dinosaurs. This is the second episode of the Willis Observatory educational series. Before I get into what killed the dinosaurs, let's have a quick eulogy for some of our favorite dinosaurs. Dinosaurs like the Velociraptor, Tyrannosaurus Rex, Barney, and Yoshi. Okay, just kidding. Barney and Yoshi are fictional, and as far as I know, they're still alive. But when did dinosaurs go extinct? Well, it was around 66 million years ago at the end of what we call the Cretaceous period. There were actually 5 mass extinctions. And this last one was the biggest one that finally was the end of the dinosaurs. Now, one big question that comes up when we do talk about mass extinctions is, are we next? Are humans going to be the next mass extinction? Well, I like to say Earth is resilient and life is delicate. Earth's going to keep on going and is still going to exist for a long time, whereas life exists in a delicate balance with the ecosystem, and if a major change happens in that ecosystem, it can cause life to dwindle. Now, unlike dinosaurs, humans can change the environment, so I think it's important for humans to go forward living in coexistence with the environment so that we can survive right alongside Earth. Now, let's take a look at the timeline of some of these extinctions that happened. Each one of these arrows points to an extinction that paleontologists have identified by looking at the fossil record. There have been some pretty big ones. The one we're concerned about is the end of the Cretaceous period, and that actually also sparks the beginning of the age of mammals, and it's marked right here. Now, why did dinosaurs go extinct? There have been many theories over the years, from supernova to aliens. This supernova, 1987A, was actually proposed to have been the demise of dinosaurs due to its strength and proximity to Earth. And it was believed that this supernova changed the climate so drastically that it killed off the dinosaurs. However, we know a lot better now, and there's actually evidence to support a different theory. Unfortunately, that theory is not aliens. The TV show Ancient Aliens tried to prove that aliens cleared out dinosaurs to make way for humans. Without any evidence to support that, I don't actually know how they tried to prove it. There's a lot more evidence of a natural disaster causing the demise of dinosaurs. And unfortunately, it wasn't aliens, even though it makes a great graphic novel, such as this one, Dinosaurs vs. Aliens by Barry Sonnenfeld. The current view is that an asteroid or a comet caused the dinosaurs' demise. So where did this asteroid or comet come from? Well, did it come from inside our own solar system? In our solar system, there's a huge array of asteroids in between Jupiter and Mars called the asteroid belt. Jupiter's massive gravity keeps asteroids locked into the asteroid belt through an interplay with its gravity and the sun's gravity. So, in a way, Jupiter kind of acts like a protector for the inner solar system, keeping those asteroids from coming in and wreaking havoc. Now, there was actually a recent paper that came out from researchers at Harvard that says that basically Jupiter acted like a kind of pinball machine and helped throw a comet into near-Earth orbit. And that's actually what caused the dinosaurs' demise. And there's a lot of evidence to support this. But first, where did that comet come from? Well, outside the solar system, there's a big collection of comets called the Oort cloud. A comet is a rocky, icy body, and they'll come in on a really long orbit, and sometimes they'll get in between Earth and the sun. Now, if Jupiter's out there playing pinball with these comets, what it can do is kick these incoming comets into orbits that bring them very close to the sun. When these large comets come really close to the sun, they can break up into smaller pieces, increasing the chance that one will hit the Earth. Here's an image of a comet that has passed too close to the sun, and you can see that it's starting to break apart. Those are all little pieces of the comet, which aren't that little, that broke off because it heated up too much. Now, when I talk about evidence that this happened, where is that evidence? Well, it's actually in Mexico, at the Chicxulub crater, off of the Yucatan Peninsula. So what happened, these authors say, is that this comet broke into small pieces, and a really large chunk of it came through the atmosphere. Now, something has to be really big and really strong to make it through all the layers of the atmosphere. Typically, asteroids will explode in the upper atmosphere, not harming the surface of the Earth. In this case, this one actually made it through, and it's estimated that 75% of all species died, and most of the surviving animals were small mammals and insects that were able to burrow underground and survive. When this asteroid, or comet, I should say, hit the Earth, not only did it create a huge shockwave and fire and earthquakes and tsunamis, it also changed the climate for decades, centuries, maybe even a millennia, because this throws dust up into the atmosphere and has the effect of cooling the Earth. The impact left a 93-mile wide crater, 12 miles deep, and it had the force of 100 million hydrogen bombs. It also just wasn't very much fun. Here we can see a satellite image of the Chicxulub crater off of the Yucatan Peninsula. As you can see, there's a tiny little scale bar on the bottom right of that image that says 20 kilometers. This thing is huge. So one question you might have is, can it happen again? Well, unfortunately, that's less of an if and more of a when. However, it's not something we should really be spending a lot of time worrying about. NASA has a planetary defense network, which is an array of satellites constantly watching the skies to track and predict possible near-Earth objects. Not only are there satellites doing that, but there are also ground-based observatories looking up into the skies to see if there's anything coming. Interestingly, there have actually been quite a few small asteroids that have disintegrated in Earth's atmosphere in the past 20 or so years. This happens pretty often, as you can see on this map. Each one of these events indicates whether or not it was day or night and the size of the explosion. And it happens all across the Earth, constantly. What's more interesting is that the more satellites and observatories we get pointed towards the sky, the more near-Earth asteroids we're discovering. In fact, that's been rising exponentially in the past 20 years because of increased attention being paid to them. Just last year, around this week, 5 near-Earth approaches happened with fairly large asteroids, some of them the size of passenger buses or passenger airplanes, and others the size of a house. So, like I said, we shouldn't worry too much because NASA and international space agencies are working around the clock to watch for objects to make sure that we don't end up like the dinosaurs. NASA funds programs to find, warn, mitigate, and coordinate. Believe it or not, there are lots of plans in case something like this happens. And people trained to respond should we ever need it. NASA works with agencies like FEMA to plan out scenarios where an asteroid does have the potential to hit the Earth, and even though they happen pretty often and explode in the atmosphere, NASA says there's only a 0.1% chance of an asteroid destroying a city per year. Now, people win the lottery in general more often than that happens. Well, thanks a lot for listening. You guys can check out that paper from Harvard by searching for this DOI number here in Google. The inspiration for this talk came from SciTech Daily, this article called "The Comet That Killed the Dinosaurs." And you can check out NASA's Planetary Defense website at this link. There were no dinosaurs harmed during this talk, and that's because they all died 66 million years ago. Well, thanks a lot, guys, and I'll see you next time. Willis Observatory is proud to be sponsored by Sky Safari, the best stargazing app for your smartphone, which is super easy to use. Open the app and hold your phone up to the sky and let augmented reality take over and teach you the night sky, star clusters, nebula, galaxies, constellations, and so much more. At Willis Observatory Star Parties, Sky Safari is particularly useful when you use our APM-24 professional binoculars with our Leonardo mount, which raises and lowers to your height and allows you to move binoculars 360 degrees and view all the night sky has to offer. Sky Safari AR is only $2.99 and works on iPhones and Androids. And you too can become a sponsor by visiting our website and clicking Become a Sponsor.